Hello everyone, today we are solving the question 81 from chapter 28. This is a classic problem on capacitor charging and the discharging. In this problem, as you can see, we will answer two main questions. First one is, what is the charge on the capacitor when the switch has been closed for a long time? And the second one is, how long does it take for the charge to drop to decrease to 10% of its initial value after the switch opens at 0 seconds. So let's go step by step. In part A, we need to find the Q. And part B, we need to find T. When the switch has been closed for a long time, the capacitor is fully charged and acts like an open circuit. It means no current flows through the capacitor anymore. Instead, current flows through the resistors. So in this circuit, the 60 ohm and the 40 ohm resistor are in series, and the capacitor is in parallel with the 40 ohm resistors. So first we need to find the total resistors. R total. It's equal to 60 ohm plus 40 ohm. It's equal to 100 ohm. And current from the battery, it's I is equal to V divided by R. 100 volt divided by 100 ohm is equal to 1 ampere. So voltage across the 40 ohm resistor will equal to V is equal to IR. It's 1 ampere times 40 ohm. It means 40 volt. It's because the capacitor is in parallel with the 40 ohm resistor, so its voltage is also the 40 volt. So in step 4, we need to use the formula like Q is equal to C times V, capacitors times voltage. Like 2 microfarad times 40 volt is well equal to 80 coulombs. So the initial charge on the capacitor is equal to 80 microcoulombs. This is our answer of A part. So in part B, in part B, T is equal to 0. The switch is opened, and now the capacitor starts to discharge through the 10 ohms and the 40 ohms resistors, which are in series. So we are asked, how long does it take for the charge to decrease to 10% of its original values? So we start from the discharge equation. It's like Q is equal to Q0 times e power of minus t divided by tau, where the tau is equal to R times C. We can rewrite minus t divided by RC. So we know from the question it will decrease the 10%. It means the Q is equal to 0.1 Q0. So substitute into the formula, we can find 0.1 Q0 is equal to Q0 times e power of minus t divided by RC. So divide both sides by Q0. That there have the 0.1 is equal to e, and take the natural logarithm, which is ln. So ln 0.1 is equal to ln e power of minus t divided by RC. We know that that will equal to the minus t divided by RC, and here only have the ln 0.1 is equal to minus t divided by RC. So we need to find the time. T is equal to minus RC times ln 0.1. This is the time it takes for the charge to decrease to 10% of the initial value. So we need to plug in values and calculate it. So equivalent resistance during the discharge is equal to 10 ohm plus 40 ohm is equal to 50 ohm. And the capacitance is equal to 2 times 10 minus 6 power of minus 6 farad. This is given directly in the circuit diagram. And we also have the ln 0.1. ln 0.1 is equal to minus 2.3. Now just put that values on this equation. We can easily find t is equal to minus 50 times 2 times 10 power of minus 6 times minus 2.3. Minus and minus will cancel it. There will equal to 0.00023 seconds, which means 0.23 milliseconds. So it takes the approximately 0.26 milliseconds for the charge to decrease to 10% of the original values. And final summarize. Let's summarize what we found. In part A, the capacitor was charged to 80 microcoulombs with a 40 volt potential difference. And in part B, after the switch opened, it took 0.23 milliseconds for the charge to decrease to 10%. This happens quickly because of the small resistance and the capacitance. These types of circuits are very common in electronics, used in timing, filtering, and the memory applications. So that's all for my video. Thanks for watching. If you found this helpful, feel free to like, share, or leave a comment.